So all of survey goes back to the number of people wanting something, say the number of people who like cats, individuals who like dogs, avocados that are oblong in shape. So you go with counts, you're counting elements. So surveys typically involve counts, and those counts go back to the elements of a set. And later on, one will say that set theory, surveys, statistics, probability, they're all connected. Here is a simple example. So I have the universal set, and I have two sets, A, B. In gray, I'll use region 1. So that's region 1. Perhaps I'll go for that color. Region 2. And in the middle, I have region 3. Let's hypothetically take counts. 21, 9, 13, and 8. Naturally, the region outside of the shaded regions, the circles, we can call it region 4. Whether you call it region sets, they're all the same. So this would be set A, that would be set B. Now, what we have here is the cardinality of each of the sets. So I have N of A union B. I can find N of A. I can find N of B. I can find N of A intersect B. I can find N of U, the entire universal set. Well, how many do we have in A union B? In order to find that, if you recall, we know the formula N of A plus N of B minus N of A intersect B. If A and B are disjoint, in other words, there is no overlap, then the third one would be 0. That's not the case. These are overlapping sets. So what do we have? We have 21 N or 4 N of A. Got to add 9 to it. So in total, we have 30. N of B, 9 plus 13. You have 22. N of A intersect B, we have 9. So when we put N of A, N of B, and N of A intersect B, one of the double counted 9s will go away. For instance, if I add those two and subtract that 9, one of the 9s will get cancelled. So if one of the 9s go away, well, I can simply write it as 30 plus 22 minus 9. That would simply give me 43. So the cardinality of A union B is 43. And directly speaking, it is simply the sum of 21, 9, and 30. Well, the cardinality of U is the sum of counts, sum of all the counts that we have. So in this case, it would simply be 21 plus 9 plus 13 plus 8. So we have 51. So we want to find the cardinality of A complement, B complement, A complement, intersect B complement. A case like this, it's best if you can draw it out. So A complement would contain elements that are not unique to the set A. Anything that is in A cannot be part of a complement. So, well, let's look at that picture. I want to account for everything that is not in A. Oh. So exclude anything that looks like A, which would mean I would want to exclude that part. So that needs to go away. That entire count, let's see, perhaps I can erase it. So that count needs to disappear. And that would simply leave us with the 13 and the 8. So 13 plus 8, 21. Repeat the same process for B complement. I've got to get rid of everything that belongs to B. So that is B, that part of it there was B. If all of those go away, I'd simply have 21 plus 8, we get 29. And lastly, I want to find whatever that is common to A complement and B complement. This is the challenging part. So if we want to find the cardinality of A complement intersect B complement, there are a couple of ways in which we can do this. But what we can do is to realize, no, A union B complement is equal to A complement intersect B complement. Those two would correspond to the same set. So they must have the same number of elements. So if I find the cardinality of this set, that would equal to the cardinality of that set. Well, we want to find the number of elements in A union B. We actually found that in the previous part. the total number of elements in A union B is 43. And I want to know the elements that do not belong in A union B. So there are total of 51 elements. Out of those 51 elements, 43 belong to A union B. That would mean 8 must belong to A union B complement. So perhaps I've got to put a bigger bracket here so you understand. So the answer would be 8.